Hi there, ladies and gentlemen. Just wanted to give you a quick walkthrough here on how to find the perimeter of any polygon, and then also find the area of rectangles in particular. We'll move through how to find the area of various other polygons as we kind of progress through this chapter on perimeter and area. So whatever day it is today, you might want to just put that in your notes so you know what day you took these on. The section that this set of notes will correspond to in your textbook will be section 5.1. And our learning target for today, so our goal, the objective here is going to be to find the perimeter of any polygon. And our other goal here is we want to determine the area of a rectangle. And so two big goals today. Now, these are topics you all are generally familiar with. You have seen these ideas before, so the goal today, we just kind of want to refresh that foundation for you and maybe extend it a little bit at the end. So first, this idea of perimeter. Right? Pretty simple idea. Perimeter of a closed plane figure, as you see here, is the distance around the figure. Okay. So if you look at this polygon in part A of number 2, for example, if we want to find the perimeter of this pentagon, it has 5 sides, so we call that a pentagon. If I want to find the perimeter of this, the work is pretty straightforward. I just add up the distances around the outside. Usually a good check in this instance. There are 5 sides. I'm adding up 5 numbers. Great. I have them all accounted for. And you can just plug that into the calculator. If you enjoy doing the mental math, please, by all means, do that. And you would get a perimeter of 23 units. Okay. Do want you to take note. These would be one-dimensional units, right? We're measuring a length, so these would be one-dimensional units. If you want to go ahead and pause for a second, go ahead and try part B. Try to find the perimeter of that hexagon. That's a 6-sided polygon. Go ahead and try that yourself, and then come back to the video, and we'll see how you did. All right, so again, we're just going to add up the length of each side, and that's going to give us the distance around the closed plane figure. So my work looks like that. Again, I can do a quick check. 1, 2, 3, 4, 5, 6 numbers. And I have 1, 2, 3, 4, 5, 6 sides. So always a good thing to check when you're calculating perimeter. If I add those up, I'm going to get 35 units. Okay? And again, it's a one-dimensional unit. We're measuring a one-dimensional quantity length. All right, so let's focus on the rectangle for a second. That's kind of where the particular polygon we're going to concentrate on today. Can we come up with a formula for finding the perimeter of a rectangle using this idea of perimeter, right? When we used it on these polygons, we did some certain things, right? We found the distance around the figure by adding up the length of each side. Can we develop a generalized pattern for the perimeter of a rectangle if we call the base B, right? Base in a rectangle, just pick any side. And if it has H for a height, okay? Height in a rectangle, that's simply going to be the length of the segment that is perpendicular to the base. So using those algebraic symbols B and H, can you pause, take a moment, can you think of a way to develop a generalized formula for the perimeter of a rectangle? All right, hopefully you had some time. All right. Now, in a rectangle, if this is the base B, this other side on the rectangle is also going to have base B as its length. And likewise, this side here is going to have a length of H, the height, just like this side does. So if you use our definition, you get B plus H plus B plus H. Right? And we can simplify this formula and have a generalized formula that we can use anytime we come across a rectangle. B plus B is 2B. H plus H is 2H. Now, again, a lot of people will ask me, are we going to have all these formulas? We're going to have a ton of formulas in this unit. We're going to look at shape after shape, a lot of shapes that we use in the real world, and kind of try to generalize some patterns with these. A lot of people ask me, am I going to have access to these formulas on the test? Yes, you will. You're welcome to use your notes. It's an online course. I understand you're going to have these resources available to you. Feel free, you can make yourself a little list. This formula goes with a rectangle. That's fine. You still need to know how to use it. That's the thing I'm most worried about. A trap a lot of students will fall into is, hey, I have all the formulas. I don't really need to think. You still need to think. There are concepts of base, height, and perimeter in here. You need to know what those mean so that you can identify them, plug them into the equations, and manipulate them. So don't think just because you have the formulas that all the work's done for you. All right, that's a trap a lot of students will fall into. Please don't fall into that trap. All right, so number 4. We have Adam here. He has recently moved into a house, and behind this house, he has a rectangular yard with the dimensions you see here, 21 feet by 13 feet. Adam wants to enclose this yard with a fence. How many feet of fence should he buy? Take a moment, think about how you'd approach this problem, give it a try. All right, hopefully you paused it, took a moment to go ahead and give it a shot. Let's see how you did. This is a rectangle, so I could use my shortcut here that we developed. 2 times the base plus 2 times the height. My base here, let's say I pick 13 as my base. That would make my height 21. So I plug that in for H. And again, if you want to do some mental math, great. If you want to just pop that expression into a calculator, get a number out for that, that's fantastic too. Either way, you should get 68 feet. Okay. So a couple things to notice. You could have switched these. So if you said the base is 21, then the height would be 13. That's the way it works on a rectangle. You can pick any side for the base. The height is the length of the side that's perpendicular. The side you chose is the base. You'll notice I'm writing units out a lot. You are welcome to use the symbols. However, I'm going to get you into that habit because when it comes to your test in this course, I always ask that you write the units out so there's no confusion with symbols. Okay, so I'm going to get you into that habit. And again, this is a one-dimensional unit, right? We're measuring length around the closed plane figure. So that is a one-dimensional unit. Again, let's read this question number 5. And again, concepts. So great, you have this formula. Great, you were able to apply that formula. What are the concepts behind this formula, right? Do you really understand what's going on here? So number 5 says, this formula we developed in number 3, right? Could we have used this formula to find the perimeter of either of these figures that we looked at in number 2, right? Would I have been able to do that? So, tell me, would I be able to do that? Go ahead and pause for a second. Tell me, would you be able to use this formula to do the ones in number 2? And then can you explain to me why or why not? All right, hopefully you had a moment to think about it. My hope is that you kind of understood the concept of this equation here, right? This formula we developed. I'm hoping you answered no. Okay, you cannot use this formula to find the perimeters for these 2 polygons. And the big reason is, again, do you understand the concept of what this formula actually represents? This formula can only be used with rectangles. Okay, and that's the big thing. Do you know that, right? If I see this equation, perimeter equals 2 times the base plus 2 times the height, do I know what that means? Do I know what shape that goes with? Do I know what all those symbols represent, P, B, and H, right? So conceptually, do you understand this is a generalized pattern for finding the perimeter of a rectangle, right? If you do, this question should be pretty easy. I definitely can't use it with a pentagon or a hexagon because they aren't rectangles. We can't use these symbols that are relevant to a rectangle to calculate perimeter for shapes that aren't rectangles. All right, so take a moment, go ahead and flip your notes over or go to the second page, however you chose to print those. And we want to move to this second idea for today, this idea of area. So again, this is something that you should be familiar with from your previous math studies. Do want to make note, this definition is a little bit more challenging than the perimeter definition. So let's dissect this a little bit. It says the area of a closed plane figure. It's the number of non-overlapping squares of a given size that will exactly cover the interior of the figure. Okay? Non-overlapping squares is really important. Okay? For example, in this figure, if we jump down to number 7, these are non-overlapping squares, right? Overlapping squares might look something like that. Okay, so we can't look at squares that look like that. They're a given size. Okay, as we jump down to number 7, one of these squares is going to represent a square yard. Okay, might be a square inch, square meter, depending on the scenario, and exactly covers the interior of the figure. So how many of these squares fit into that figure, right? That's what we're counting with area. How many squares of this given size will fit into this figure? Let's do it. Best way to kind of look at this definition, let's do an example with it, okay? So supporters of the Northland Public Library have decided to buy new carpet for the main floor. That main floor is rectangular in shape. A carpet installer makes a scale drawing of the floor as we see here. All right. We want to know how many square yards of carpeting should the installer bring to the library for the project. And again, note that each of these squares that he sketched, that represents 1 square yard. Pause, take a moment, go ahead and can you give me an answer to this question? How many square yards of carpet should he bring to the library for the project? All right, so hopefully you had a chance to think through that. Usually I'll get an explanation that goes something like this. Well, I counted 1, 2, 3, 4, 5, 6, 7. There were 8 rows. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. Right. I'll get some explanation that kind of looks like that. Okay. And then, a student will say to me, oh, well, I took 8 times 10 and that got me 80. Right? So that's how many square yards the carpet installer should purchase. I think that's a fine way to do it, right? That's a good shortcut for figuring out how many squares are here instead of, counting each individual square and going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and so on, right? So that's a really good shortcut to do that. That should bring us to a really nice generalized pattern for finding the area of a rectangle that has a base B and a height H. Okay. Again, something you guys should be pretty familiar with. If you're not for any reason, this is something you can quickly generalize. But we'll say the area of a rectangle is found by taking the base B and multiplying it by the height H. Okay. Something you guys are usually pretty familiar with. All right, so let's take this and try to apply it. If you look at number 9, our buddy Adam here from the front page also wants to plant grass seed in his new yard. How many square feet will he need to cover? Right, this would be important to know so you could go buy the seed you want. Take a moment, go ahead, try to apply this formula so that we can find the area of this rectangular region. All right, this one should be pretty straightforward. Area is base times height. Let's say you choose your base is 13. Your height would then be 21. Multiply those things together. You should get 273 square feet. Okay. And again, you're going to need to notice here a couple things. You could have said 21 times 13. You could have said my base is 21, which makes my height 13. Great, you'll still get here. Also, you're going to note that these are square units now, right? Think about what area is. We are measuring the number of squares that will cover the interior. So we need square units. It's this many square feet, right? And again, conceptually, I kind of glossed over this in number 7, but maybe I should revisit it. Like, what is a square foot? What is a square yard, right? If you're thinking about in number 7, a square yard, it's a square for which all the sides are 1 yard in length, right? for a square foot here in number 9. Well, what's a square foot? A square foot is a square that is 1 foot long on all sides, right? So conceptually, what does that mean, right? These things are, we're going to keep building, and if you have a shaky foundation, you don't understand these concepts, it's going to be harder to learn those more complex ideas, right? So make sure you understand those concepts. All right, lastly, kick it up a notch here. 10 says, find the perimeter area of the polygon below. You can assume all the angles in this figure are right angles. Okay, so I'll give you a couple minutes here. Go ahead and pause. Take a moment. Do you have any ideas on how you can find the perimeter and area of this polygon here, which is a 1, 2, 3, 4, 5, 6 hexagon? Okay, take as much time as you need. Pause the video and give it a shot. All right, so hang tight. I'm going to give you one of the ideas I have, and then I'll show you some alternative ways that people will handle this. A lot of people will do the perimeter first, right? So we're just going to add up the lengths. Probably the most common mistake I'll see. I'll have people that kind of jump into doing this. They will say, sorry, I'm going to zoom out just a tad to make sure everything's in the frame. I'll see this. This will be the work. They add a number, they get, looks like 22.5 that comes out to, and they're done, right? Only problem is, remember earlier, and this is what I mean with the concepts, right? On the front page when we were calculating perimeter, I said, a good check is to look at how many numbers you're adding up and how many sides the figure has and make sure those match up. So I'm adding up 4 numbers. 1, 2, 3, 4, 5, 6. There are 6 sides, right? It's a hexagon. So right away, conceptually, I can tell you don't really understand what perimeter means. You didn't add up the entire distance around the figure, and that's what we need here. So how do I do that? Well, I use this idea of segment addition that we talked about earlier in the course, right? If this is 8 units long and this is 2.5 units long, if I do 8 minus 2.5, I get 5.5, and that's going to give me the length of this segment right here. Right, this segment plus this segment has to be equal to that segment, right? Because we have all right angles in this figure, and these are parallel to this. Sorry, make sure I darken that decimal in so you can see it. Likewise, if this is 9 and this is 3, then the length of this segment would have to be 9 minus 3, or 6. Right? So this would be 6 units long. All right, so now when I come to my perimeter work, now I have 6 numbers to work with. I have 6 sides, so I need 6 lengths to add up. And now I'm going to do that. And again, pop those into a calculator, do your mental math, whichever you prefer. It should come out to 34 units. Okay, again, one-dimensional units because we are measuring a length, a one-dimensional quantity. Okay. All right, now area. You have some different options here. Okay, I'm going to show you my preference. I know there are other ways to do it. We'll talk about some of those after I show you my preference here. So what I would do, I would divide this up into 2 rectangles, and I would call this area 1 and this area 2. And my total area I'm going to find by finding the area of this rectangle and just adding them up. Okay. So area 1 would be base 1 times height 1. You'll notice my subscripts. That's just to indicate them on this first triangle. First base would be 3. First height would be 8. It'll give me an area of 24 square units. All right. Second area, also a rectangle. I want that second base times that second height. Second base, 2.5. Second height, 6. And that comes out to 15 square units. Most common error I'll see here is people use the wrong length for that second rectangle you created. Like I'll have people do 2.5 times 9. 9 is the length of this segment. I need the length of this segment, right, which is 6. So just make sure you're picking the right length there when you do that. Now the total area, which I need, I'm just going to add up area 1 and area 2, the two areas of those rectangles. So that's going to be 24 plus 15. My final answer, 39 square units. One way to do it. There are multiple ways. So I will also see people, some people will draw the rectangle. So this is rectangle 1 right here, right? And then this is rectangle 2 right here. So their work would look a little bit different, right? They would do 3 times 5.5 for their rectangle, right? Base times height. That would get them to 16 and a half. And then their second rectangle would be 9 times 2.5. Okay, that gets you to, what's that? 9 times 2.5, 18, 4.5, 22 and a half. So you add those up, 22 and a half, 16 and a half, should get you to your 39 square units. Okay. Another thing I've seen people do, which I think is pretty creative, is they'll draw this big outer rectangle, right? And they'll find the area of this whole rectangle, which would be 9 times 8, or 72 square units. And then they'll find the area of this rectangle, 6 times 5 and a half, 33. So they'll do 72 and then subtract out this area to get the area of all this. Right? So 72 minus that 33 would also get you to the 39 square units. Again, all great options. And you could do others. I've seen some people do 3 rectangles. They do this one, and this one. That works as well. Okay. But anytime you have a figure composed of these rectangles, good tactic is to break those down into component rectangles, find those easier areas, and then add or subtract them as necessary, as the concepts dictate. Right. So again, that's just one strategy for it. I named a couple others. Use the one that's most comfortable for you, the one that comes to you, the one that's intuitive for you. Right. That's the goal of math, is to pick up on those patterns and make it easy on yourself. Hopefully that helped. As always, if you have any questions, concerns, please get in touch with me and we'll iron them out. Thank you.